It's resolved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Hello students, welcome to S Chand Academy, the official YouTube channel of S Chand Publishing. This is Mathematics for IIT JEE Main and Advanced by ML Khanna sir and videos by me, Subbu Nadeem. The chapter which we are going to do today is the last chapter of volume 1 of the book, that is pair of straight lines. Pair of straight lines is chapter 19 after circles. So let us do first few important concepts here. Pair of straight line, how does it come into existence? So if there are two straight lines and one equation is a1x plus b1y plus c1 is equal to 0. Another equation is a2x plus b2y plus c2 is equal to 0. Then a point which lies on this pair of a straight line, any one of the lines, will satisfy the equation a1x plus b1y plus c1 into a2x plus b2y plus c2 is equal to 0. So this is called the pair of a straight line. That means any point which lies any one of the lines will satisfy this equation, and which does not lie any of these lines will not satisfy this equation. Now if you simplify this and you make some constants simplified, then it will be ax square plus by square plus 2hxy plus 2gx plus 2fy plus c is equal to 0. So these two are alike. You can multiply them and see the coefficients of x square, y square, and you can take them proportional so that you can get the value of a, b, h, g, f, c. So this is the general equation of a pair of a straight line, and any general equation of a pair of a straight line is resembling a pair of a straight line. That means any general equation in 2 degree in x and y is resembling a pair of a straight line only if delta is equal to 0. What is delta? Delta is diagonal elements a, b, c and non-diagonal elements like this. Its determinant is equal to 0. So this is the condition for the pair of straight lines to exist from a 2 degree equation in x and y. So let me write it here. For pair of straight lines, this is the condition. Now if we suppose one line is passing through the origin and another line is not passing through the origin. So one is a1x plus b1y is equal to 0. Another is a2x plus b2y plus c2 is equal to 0. Then you will multiply and you will again get a pair of a straight line, and its general form will be ax square plus 2hxy plus by square plus 2gx plus 2fy is equal to 0. C will not be present there because here it is passing through the origin. If both the straight lines are intersecting at the origin, that is both of them are passing through the origin, then the general equation is homogeneous in x and y of 2 degree. Ax square plus 2hxy plus by square is equal to 0. So these are some of the cases which we have to understand. Further, when we take a line y is equal to m1x and one another line y is equal to m2x, both are intersecting at origin, and when you want to find the angle between them, you know that tan theta is equal to, where theta is angle between them, mod of m1 minus m2 by 1 plus m1 m2. Now the general equation corresponding this can be obtained from y minus m1x into y minus m2x is equal to 0. When you simplify this, it will have the form ax square plus 2hxy plus by square is equal to 0. And when you take the constants proportional, that is the coefficient of x square, coefficient of xy and y square proportional, because both are the same pair of straight lines, you will find the formula that angle between the straight lines within this pair of straight lines is actually 2 root over h square minus ab upon a plus b mod when you take the acute angle. When you take obtuse angle, it will be minus of it. So these are some of the formula which we have to remember. Further, if two straight lines are there, a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, and you write a general equation in x and y which is of a straight line, that is delta is equal to 0, then in that case, here basically again the question arises, what is the angle between these two lines? So tan theta depends upon, again same on h and ab only, not g, f and c. So this will be a plus b mod. That means if you shift it and pass it through origin somewhere 0 comma 0, take it parallel to this line, take it parallel to this line, then this pair of a straight line will be ax square plus 2hxy plus by square. So you don't have to take the x, y and constant terms there. Now when we start some question on a pair of straight lines, let us do them. From a point a1 comma 1, straight lines AL and AM are drawn at right angles to the pair of straight lines 3x square plus 7xy minus 2y square is equal to 0. Find the equation of pair of straight lines AL and AM. Also find the area of the quadrilateral ALOM, where O is the origin of coordinates. So first of all, you have to understand here, don't think about a1 comma 1 right now. Just think that there are two straight lines which are at right angle to the pair of straight lines 3x square plus 7xy minus 2y square is equal to 0. So pair of straight line at right angles to the given pair of straight line is given by the formula. So first of all, if the given pair of straight line is ax square plus by square plus 2hxy is equal to 0, clearly it is passing through the origin pair of straight lines. Then pair of straight line at right angle will be bx square minus 2hxy plus ay square is equal to 0. That is, the coefficient of x square and y square will get interchanged, and the coefficient of xy will also be of opposite sign. Now if we see here, it is 3x square plus 7xy minus 2y square is equal to 0. So here also we write it like this, that minus 2x square minus 7xy plus 3y square is equal to 0. Right? So this is the pair of a straight line which is perpendicular to the given pair of straight lines, and it is also passing through origin. But further the question says that it is from a point a1 comma 1. So you are shifting it, the point of intersection is shifted from origin to a1 comma 1. So by translation of axis, this shifting will result in minus 2x minus 1 whole square minus 7x minus 1 into y minus 1 plus 3y minus 1 whole square equal to 0 after shifting. So after shifting you get this. Now when you open it, minus 2x square minus 2x plus 1, this is x square, minus 7xy minus x minus y plus 1 plus 3y square minus 2y plus 1 equal to 0. So this will become minus 2x square plus 3y square. What about xy? It will be minus 7xy, then plus 4x plus 7x is 11x So plus 11x. What about y? Minus 6y plus 7y. That will be plus y. And constant from here will be minus 2. From here will be minus 7, that is minus 9. Plus 3, that will be minus 6, is equal to 0. So you can say that this is the required pair of a straight line which is perpendicular to the given pair of straight line, and it is at right angle. So this is how we will solve it, and it is also passing through the point A1, 1. Show that the difference of the tangents of the angles which the lines this is a pair of straight line passing through origin, make with the axis of x is 2. So they are saying that tan theta 1 minus tan theta 2 is equal to 2, that we have to prove, which means m1 minus m2, which implies root over m1 plus m2 whole square minus 4 m1 m2. Now when you see this equation here, you can write it like this, that it is sine square alpha y by x whole square. I am dividing by x square throughout, minus 2 tan alpha y by x, and then plus tan square alpha plus cos square alpha is equal to 0. So sum of the slopes is actually y by x, it has two values. Slope is actually y by x and it has two values, because y by x is the slope of a line which is passing through the origin. So m1 plus m2 is minus b by a, that is 2 tan alpha by sine square alpha, and m1 m2 is c by a, that is tan square alpha plus cos square alpha upon sine square alpha. Now when you calculate it, this will be root over m1 plus m2 whole square, that will be 4 tan square alpha by sine to the power 4 alpha, minus 4 m1 m2 will be minus 4 tan square alpha plus cos square alpha by sine square alpha. So this is what we will do here. Next, let us take common sine to the power 4 alpha. So this will be 1 by sine square alpha. Also let us take 2 common, that is 4 inside the under root. So this will be root over tan square alpha minus sine square alpha into tan square alpha minus sine square alpha into cos square alpha. So this will be 2 by sine square alpha here, and here it will be sine square alpha into tan square alpha. So this will become tan square alpha into 1 minus sine square alpha, that is cos square alpha. So you write it tan square alpha into cos square alpha minus sine square alpha into cos square alpha. Further you take cos alpha common. So this will be 2 cos alpha by sine square alpha, and inside the under root it is tan square alpha minus sine square alpha, which can be written as sine square alpha upon cos square alpha minus sine square alpha. So this will become 1 minus cos square alpha upon cos square alpha. This is like this. In the next step, it will be 2 cos alpha by sine square alpha into, this will become also sine square alpha. So this will become, after taking from under root, sine square alpha by cos alpha. This will be 2 finally, as you cancel cos alpha and you cancel sine square alpha. So this is what you had to prove, that it make with the axis of x is 2. So difference of the slopes is 2, which you had to prove. So hence proved here. But you have to remember this fact, that y by x in a homogeneous 2-degree equation represents slope of a line. So if there are 2 values of y by x, which is mostly possible, so then there are 2 lines whose 2 slopes are given. If suppose it is a coincident pair of straight lines, then only one value of y by x will be obtained, that is only one value of m will be there. If the two lines are imaginary, that is there are no possibility of that two pair of straight lines, then their slope value, that is y by x, will be not real, that is discriminant will be less than 0 of the quadratic in y by x. Let us come to the next question. Prove that each of the lines given by the equation, this one, is at a distance a from the point x1 comma y1. So this pair of straight lines is passing through origin because it is homogeneous in x and y, 2 degree equation x and y, and it is homogeneous. So any line which is homogeneous means it is a pair of straight line passing through origin. So let us suppose y is equal to mx is one line, and that line is represented by this pair of straight lines. Prove that each of the lines given by the equation has a distance a from the point x1 y1. So from x1 y1, if we want to find the distance of mx minus y is equal to 0, it is a. So a is equal to mod of mx1 minus y1 by root over 1 plus m square. Now what is the slope? Slope of the line is actually y by x in this pair of straight lines. So we can say that where m is equal to y by x. So a is equal to y x1 minus y1 x by root over x square plus y square. In the next one, let us cross multiply. So it will be a square into x square plus y square is equal to y x1 minus y1 x whole square. So this is the equation of the pair of straight lines, and this is matching with the pair of straight line equation which is given in the question. Hence we can say that yes, this gives a pair of straight line which is at a distance a from x1 comma y1. So hence proved. Next question we have, it says if one of the lines given by the equation 2x square plus axy plus 3y square is equal to 0 coincides with one of the lines given by 2x square plus bxy minus 3y square equal to 0, and the other lines represented by them be perpendicular, then prove that a by b is equal to 5. So little bit of calculation is here, but no issue, we will do that. If one of the lines given by the equation, this one, again passing through the origin, both the lines, coincides with one of the lines given by this one. So first line y minus mx is same in both the equations, and the other line represented by them be perpendicular. So this is y minus m1x and this is y plus 1 by m1x, because other line is perpendicular to each other. So product of the slope is equal to minus 1. This is 0, this is 0. This becomes y square minus plus m1 x square minus m1 plus m xy is equal to 0, and this is same as this equation, which is 2x square plus axy plus 3y square is equal to 0. Another one, this one, when you multiply you will get y square minus m upon m1x square and plus 1 by m1 minus m xy is equal to 0, and this is same as 2x square plus bxy minus 3y square is equal to 0. Now, okay, now let us take the coefficients proportional. So in the first set of equations, 1 by 2 is equal to m1 by a is equal to minus m1 plus m upon 3. In the second set of equation, it is 1 by 2 is equal to minus m by m1b is equal to minus 3 plus 1 by m1 minus m upon minus 3, right? Now if we equate this with this and this with this, what we will get? We will get m1 plus m is equal to minus 3 by 2, and from here it will become 1 by m1 minus m is equal to minus 3 by 2. Now let us add them. So therefore m1 plus 1 by m1 is equal to minus 3, which implies that this will be m1 square plus 3m1 plus 1 is equal to 0. Now m1 value will come out from here, minus b plus minus root over b square minus 4ac by 2a. Okay, and m value will also come from there. But what we are interested in, a by b. So let us not go into the calculation of m1. Let us concentrate on a and b. So I am erasing this portion. I am not getting the answer of m1. Instead I am focusing on a and b. So whatever value of m1 m from you get here, from next one, when you divide these two, what you get? Half cancel, it will be 1. Half cancel, it will be 1. mm will cancel, and m1 square minus m1 square upon m1, mm will cancel, m1 square upon a by b. So you will get a by b is equal to minus m1 square. Now minus m1 square value you can obtain from here. I left the calculation part, and you get a by b is equal to 5. Okay students, let us move on to the next question. If x square minus 3xy plus lambda y square plus 3x minus 5y plus 2 equal to 0 represents a pair of straight lines, then the value of lambda is 1, 4, 3, 2. Also determine the equation of the lines. So first of all, delta should be equal to 0. What is delta? A, B, C diagonal elements 1, lambda 2, and F, G, H. F is minus 5 by 2, G is 3 by 2, and H is minus 3 by 2 is equal to 0. This implies 1, 2 lambda minus 25 upon 4, then plus 3 by 2 minus 3 plus 15 by 4. We all know how to expand a determinant. Plus 3 by 2, 15 by 4 minus 3 lambda by 2 is equal to 0. So 2 lambda from here and minus 9 by 4 lambda from here. So 2 minus 9 by 4 lambda we take, then minus 25 by 4 from here. From here it will become 15 minus 12, 3 by 4, 3, 3, 9 by 8. From here again 45 by 8 is equal to 0. So this will become minus lambda by 4, and LCM will be 8 here. This will be minus 50. This will be 9. This will be 45. This is 0. So 45 plus 9 is 54, minus 50 is 4. 4 upon 8 is 1 by 2. So minus lambda by 4 plus 1 upon 2 is equal to 0, which implies lambda is equal to 2. This is our answer. So value of lambda is equal to 2. When you put the value of lambda is equal to 2, you can also by factorization find the pair of straight lines. Prove that the straight lines ax square plus 2hxy plus by square equal to 0 have the same pair of bisectors as those of the lines given by this. So what is the condition for having angle bisectors? So if this is the pair of a straight line, the angle bisector is actually x square minus y square by coefficient of x minus coefficient of y is equal to xy upon half into coefficient of xy. So this will be x square minus y square. In this first case, it will be a minus b is equal to xy upon h. For this first case, this is half into coefficient of xy. In the second case, it will be x square minus y square upon a square minus b square is equal to xy upon h into a plus b. Now from a plus b, a minus b here, you will cancel a plus b. So this will be x square minus y square by a minus b is equal to xy by h. Now both the equations are same. That means the angle bisector of this equation and angle bisector of this equation is same. So this is the condition of angle bisectors. This is how you get angle bisectors. So we have the next question here. Prove that the equation 8x square plus 8xy plus 2y square plus 26x plus 13y plus 15 equal to 0 represents two parallel straight lines and find the distance between them. So you have to show that this represents two parallel straight lines and then you have to find the distance between them. So first let us find tan theta, that the angle between them, 2 root over h square. So h square will be 4 square minus AB is 8 into 2 upon A plus B is 8 plus 2. So this will be 0. That is theta is equal to 0, as 16 minus 16 is 0. So yes, these are two parallel straight lines. Next we have to find the distance between them. So in order to find the distance between them, what we can do here is we can factorize, or we can directly use the concept of two straight lines ax plus by plus c1 is equal to 0 and ax plus by plus c2 is equal to 0. As these are parallel, so AB is same in both the lines. So this will give you a square x square plus b square y square plus 2ab xy, then we have c1 ax plus c2 ax. So c1 plus c2 ax plus c1 by plus c2 by. So c1 plus c2 by plus c1 c2 is equal to 0. Now this basically is a pair of a straight line which is same as this. So what you can do is take the coefficients proportional. 8 by a square is equal to 8 by 2ab is equal to 2 by b square is equal to 26 by c1 plus c2 a is equal to 13 upon c1 plus c2 b is equal to 15 upon c1 c2. Now if you equate these two, suppose you will get b by a will cancel as 1 by 2, and if you equate these two, b by a is 1 by 2 from here also, both the places. So b by a is 1 by 2. Now let us suppose that a is equal to 2k and b is equal to k. So what will be this becoming? 8 by a square, that will become 4k square. So 2 upon k square, 8 upon 2ab, 2 upon k square, this will also become, and 2 upon k square, this will also become. So all three are 2 upon k square. This will become, a is taken as 2k, so 13 by k c1 plus c2, and here 13 upon k c1 plus c2 again. 15 upon c1 c2 will become 15 upon c1 c2 as it is. Now if you equate these two, you will get c1 plus c2 as 13 by 2k, and if you equate this with this, you will get c1 into c2 is equal to 15k square by 2. Now you have to find the distance. And what is the distance? Distance is mod of c1 minus c2 by root over a square plus b square. So what will be mod of c1 minus c2? That will be root over c1 plus c2 whole square, that is 169 by 4 k square minus 4 c1 c2, that will become 30 k square. In the denominator, a square plus b square will become root over 5 k. So this will become, kk will get cancelled because k square will come out of the root, and this will become 169 minus 120, that is 49 under root is 7 by 2 root 5. So this is the distance between these pair of straight lines. So what we have to do, first we have to find the angle between them, which is coming out to be 0. Then we take the two lines such that these two lines are parallel. So the only difference is between c1, c2, rest coefficients are same as they are parallel. Now make the pair of a straight line and take the coefficients with this given pair of a straight line as proportional. Then further solve it and get the value of the distance. Let us come to the next question. Find the equation of the lines joining the origin to the points of intersection of the line 4x minus 3y is equal to 10 with the circle x square plus y square plus 3x minus 6y minus 20 equal to 0, and show that they are perpendicular. So this is a line and it is intersecting a circle, and from origin you have to find the pair of straight lines which is intersecting at their point of intersection. So how do we do this? We do this by homogenization. In homogenization, what do? We try to homogenize the equation. So this equation is 4x minus 3y is equal to 10. That is 4x minus 3y by 10 is equal to 1. And this equation will become x square plus y square plus 3x into 1. And 1 we will take as 4x minus 3y by 10 minus 6y. So minus 6y into 4x minus 3y by 10 minus 20 is equal to 0. So this will become x square plus y square plus 12x square 9xy, from here minus 24xy plus 18y square upon 10 minus 20 is equal to 0. So this will become 10x square from here plus 12x square, 22x square, and 10y square from here plus 18y square, 28y square, and then we have minus 24 and minus 9, that is minus 33xy, and minus 20 also we need to homogenize. We can't leave minus 20 as it is. So how do we homogenize minus 20? 4x minus 3y by 10 whole square is equal to 0. So this is becoming 4x minus 3y by 10 whole square is equal to 0. So this is upon 10, and rest is minus 20 upon 100 into 16x square plus 9y square minus 24xy is equal to 0. So you can calculate this. I am not going into the calculation part. It is simple calculation. Calculate this and find the equation which is the required pair of a straight line passing through origin, which is intersecting these two at their point of intersection. Find the condition that the lines joining the origin to the point of intersection of the curves, this one and this one, be perpendicular. So again we need to homogenize here. How do we homogenize? Let us multiply with G1 here and let us multiply with G here and then subtract. So when you will do this, this will become AG1 minus A1G x square plus 2HG1 minus H1G xy plus BG1 minus B1G y square, and 2GG1x minus 2GG1x will cancel. This is equal to 0. And now we have to find the condition that these two curves are perpendicular. So therefore, coefficient of x square plus coefficient of y square should be equal to 0 for them to be perpendicular. So what is condition of coefficient of x square? That is AG1 minus A1G. Coefficient of y square is BG1 minus B1G is equal to 0. So here it will become A plus BG1, and on the right side it will become A1 plus B1G. So we can say that this is the condition for them to be perpendicular. So these are some of the questions, and now there is one more question here. The equation x square y square minus 2xy square minus 3y square minus 4x square y plus 8xy plus 12y equal to 0 represents a pair of lines on a circle, a pair of lines on a parabola, 4 lines forming a square. So in order to do this, what we do here, let us see, can we take something common here? Y can be taken as common from all of them. So y common, x square y minus 2xy minus 3y minus 4x square plus 8x plus 12 is equal to 0. So one line will come, y is equal to 0. This is one line. Now rest, this is remaining. So what you can do for them is, let us analyze about factorization. 3, 4, 12, 2, 4, 8, yeah. So from here and here I am taking x square common. This is y minus 4. From here and here I am taking minus 2x common, y minus 4. And from here I am taking minus 3 common, y minus 4 is equal to 0. So y minus 4 is common overall, and inside it is x square minus 2x minus 3 is equal to 0. So y is equal to 4 is one condition. So there is one more line, y is equal to 4. What about this? We can factorize it like this, x square minus 3x plus x minus 3 is equal to 0. So this will become x minus 3, x plus 1 into x minus 3 is equal to 0. So two other lines are x is equal to minus 1 and x is equal to 3. So there are actually 4 lines and all the 4 lines are perpendicular to each other and they are forming a square. Y equal to 0 is the x-axis, y is equal to 4 is at a distance 4 unit from here, x is equal to minus 1 is here, and 4 units later you get x is equal to 3. So this forms a square. So we can say that 4 lines forming a square it is representing. So these are all the questions from pair of straight line students. All the best. Thank you.